Okay, so proofs. Now, there are going to be proofs on the FSA. I could almost guarantee that. There are 3 different types of proofs that we've done, and most of the proofs we did, we focused on at the beginning of the year, because those are the things that we really focus on proofs the most for. Now, could they ask you to do a proof on anything from the year? Sure, they could. Again, most of the time, they come from the sections that we focused on proofs from, though. So, like, the triangle section, where we're doing triangle congruency, that's usually the part that's the heaviest with proofs. Now, there were 3 types of proofs. There was the 2-column proof, like this, which I would say on all the previous FSAs, you see the most questions for proofs are usually 2 columns. The next biggest one, I'd actually say, yes, I know there's flowcharts, and I've seen flowcharts on there, but they actually, I think, second most is something like a paragraph proof. Again, we've done a few paragraph proofs, so this one was from actually we had 2 from tests, but I'll go over some paragraph proofs with you as well. No matter what type of proof it is, they're all the same. Same idea. You have statements, you have reasons. You have to start with your statement from the very beginning that's given to you, and you have to work down to the statement that you're trying to prove. For every statement, you have to include some type of reason with it, right? So again, statements and reasons. It's a logical thinking process to get from what's being told to you to what you're trying to figure out. Now, they could give you proofs from any point in the year. So they could also want you to figure out different ways. So depending on what information they give you, yes, there might be more than one way to actually do the proof. But you have to look at all the little context clues as to what other parts they're giving you and what other steps they are to make sure that you're doing it how it's presented. Because we learn many different theorems. And some of those theorems we learned later on, some of them we learned early. And again, could you use some of those theorems later on to prove a proof faster? Yes. Is that the way that they might be going through the proof that's given to you? Not necessarily. So again, you have to look and see what information is given to you, because most of the proofs that they give you, they're going to give you some of the steps already filled in. Now, sometimes they'll give you proofs where you have a drag and drop, and you saw a drag and drop style question. I've also seen proofs where you have a drop down menu. So like there will be a box where you click on it and then multiple options appear. I've seen ones that are multiple choice, like which one goes in this blank. Again, they can ask proof questions several different ways, and you'll probably see them several different ways. So I have not seen a proof where you had to type in. Could they ask you to do that, though? They could, but highly unlikely. All right? So again, most of the proof stuff I've seen on an FSA before is usually some type of multiple choice, drag and drop, word bank, multiple choice, those types of questions. All right? Questions so far? All right. Now, whenever we do a proof, remember, you should start a proof by identifying your givens. Now, do you necessarily have to put the given as the first step? No. Do you sometimes have more than one given?
Yes.
Will they sometimes split up the givens?
Yes.
All right, so again, the givens don't necessarily have to start at the beginning. They could be split up into several places. The final step, though, has to always be what you're trying to prove. Should you ever use prove as a reason? Should you ever use prove as a reason? Will they probably put prove as something that you could drag and drop? Probably. Don't ever use it. All right? Again, prove is not a reason in a proof. The only things that you can use for reasons, there's 5 of them. All right? There's given or given information. Again, the way they say given could be a couple different things. They could just say given. They could say given information, given information. But they'll say given in there somewhere. So the given. You have properties, postulates, theorems, and definitions. All right? Those are the 5. All right? So again, you have given, you have properties, postulates, theorems, and definitions. Those are the only 5 things you can use as reasons. Now, some of the theorems, some of the postulates didn't actually use the word theorem or postulate. Like, for example, all right angles are congruent. That was the name of a postulate that is accepted as true, but again, it doesn't have the word postulate. But it was one of the first postulates we had. And again, it's just, that's the full name of it. all right angles are congruent. It actually says exactly what it is. There's no short name for it. All right. So going through some of these. Now, I pulled proofs off of 4 different chapters that we did. Some of these are from quizzes. Some of them are from tests. So wide variety of different types of proofs that we've had. All right. This first one is dealing with parallel lines. So on this one, we have given that these 2 lines are parallel. So looking at this, they wrote B and C are parallel. So reason, given, or given information. Again, one of the options should say something about given. Then on the second one, all right, angle 1 is congruent to, well, there's lots of angles it could be congruent to, but look at the reason they gave us. Corresponding angles. You said angle 5. Because corresponding angles are angles that are in the same position. So 1 and 5 are in the same position. So those are corresponding angles. Corresponding angles are congruent. Now, out of all the parallel line theorems and postulates that we had, this one is the one that's usually referred to as a postulate. The rest are theorems. So corresponding angles, postulate. Now, the next one. This one has nothing to do with parallel lines. 5 and 7. What type of angles are 5 and 7? Vertical. So this is vertical angle theorem. All right. Again, it's not just the definition of vertical angles. Vertical angle, the definition, doesn't tell us anything about them being congruent, right? Vertical angle theorem tells us that the angles are actually congruent. Now, this blank, well, they left this pretty wide open. But again, use your context clues. Look what comes next. All right? Measured angle 1 is equal to measured angle 7. Well, in order to say that and state the definition of congruent angles, we must have first known that they were what? Congruent. Did it say anywhere above that those 2 are congruent? No, but look, we have a congruent symbol here. So, angle 1 is congruent to angle 7. That's the only thing that could have came... Shh, guys. That's the only thing that could have come before this statement if we're saying definition of congruent angles. Because if you say anything dealing with definition of congruency, anything, guys, anything dealing with definition of congruency does one of 2 things. It either takes equal signs and makes it into congruent, or congruent signs and makes it into equal, right? That's all any definition of congruency does. Whether you just say definition of congruency, or if you're more specific and say, here we're talking about angles, so we say definition of congruent angles. If you're talking about line segments, definition of congruent segments. Again, any definition of congruency only changes our symbols, talking about the figures themselves and saying that their measures are equal. All right. Now, we do have one other blank here. How do we know that angle 1 and angle 7 are congruent?
No, because it's going off of the last
2.
And I don't remember.
So this is where there's some debate. Shh. Now, most of you guys, listen. If it's an option, alternate exterior angle theorem would work. But on this problem, I'm going to guess that's not going to be there. Because these 2 previous ones give you enough information to say that they are congruent. Because you could either say substitution property, or, better yet, transitive property.
Okay, so basically you're taking the
So, again,
and plugging it in. Okay, so you see how it says...
let me explain it first, and then if I need to add something, you can. All right? So, on here, both of these were equal to 5, right, or congruent to 5. Yes? So, since they're both congruent to 5, then they must be congruent to each other. That's transitive property. If you have 2 pieces congruent to the same piece, then they're congruent to each other. That's transitive property of congruency. You could also, if you had equal signs, say transitive property of equality. Now, substitution property. That also works because you could say that if this is equal to 5, you replaced 5 with 1 and got that same expression. That would also work. So substitution and transitive work hand in hand. Now, I doubt that they're going to do this top one, but again, that's where most of these are multiple choice. So one of these three things would be a possibility. All right? You're not going to see all three of these as choices, though. So again, you got to remember, there are different ways to do a proof. At this point in the year, we hadn't really done this one yet. All right? So this one we talked about afterwards, all right, after this section. I think this was from a quiz that we had done. All right? So we hadn't talked about this one yet, so that wouldn't have been something we could have used yet. But these two, we had already talked about, so you could have used either of those. All right? Any questions? All right, let's move on. Now, this one was when we got into a lot more of two-column proofs, and we're talking about how to work proofs and things like that. So this one was just using algebra and some of our algebra properties. Yes, you can see some of your algebra properties on the FSA because they are included in this school year. So I've seen some of these appear because for different proofs, we had to use some of these properties. Now, guys, on here, they give you an equation and they want you to prove this. Well, we know these two things should be in our proof, right? This should definitely be the last step. And since this doesn't appear anywhere else, that must be our first step. And if that's our first step, our reason for that would be... Now, what happens from here to here? Distributive property, yeah. So, now, all right, again, I don't think they would ever put equality after that. Do some books do it every once in a while? Yes. But should distributive property be of equality? No, because are you doing something to both sides of the equation? No. Again, when you say property of equality, it's because on both sides of the equal sign, you're applying the same property to both sides to make them equivalent, right? Distributive property, again, you're not really applying something to both sides. Now, the argument there with some books is that you're replacing something with an equivalent value. But again, usually if you're saying property of equality, most books will agree that it's because you're doing it to both sides of your equation. Right? So now, once you use distributive property, then you use addition property. Now, the other thing you have to keep in mind here is, guys, addition property and subtraction property. Those two can be used pretty much interchangeably. Somebody in my last class said on one of the assignments on Math Nation, they wanted to put subtraction property of equality, but it wasn't a choice. Addition property of equality was, but they didn't select it because they thought it was subtraction property of equality. The answer was addition property of equality. What you have to remember is, if you subtract a value, that's the same thing as adding a negative, right? So again, you can argue subtraction property of equality or addition property of equality for most problems. Now, if you know that you're doing a negative value and you have that as an option, then you want to do subtraction property of equality. But if you don't have subtraction property of equality and you're subtracting something and addition property of equality is there, you can say you're adding that negative number and addition property of equality would work. All right? Now, on here, let's see. The one step we're missing. This would definitely be, I would use subtraction property of equality. Again, this is where you could argue, could you also say addition property of equality again? Yes. Oops. All right. Moving on. So now, here's another two-column proof. We have lots of information given. Now, could you do this proof many different ways?
Probably.
Yeah, there's a lot of different properties that we could use here. Now, I gave you options. And these are the only options to choose from. So again, based on what's given to you, there's only one way to do this. So again, you have to go through and identify the correct parts. So what should go into that first blank? A. All right. So measure of GE is equal to 155 degrees. What should go into the last blank? B. All right. The statement we're trying to prove. Now, going through this, we have lots of other steps here. Now, some of these you could argue other things, but again, for the proof to make sense and to follow the order that you're going in, there's only one way that you should do these. So, on this one, say it again. Angle addition. Again, if you look at this, what are you doing? You're adding two angles and equaling it to the bigger angle. That is angle addition postulate. So that's H. Angle addition postulate. Remember, postulates are those things that didn't have to be proven. A theorem had to be proven.
Next is definition of supplementary.
Is it? Do you have?
No, straight angle.
It's a straight angle. So again, difference between definition of supplementary and straight angle. Straight angle, you're only talking about one angle. Definition of supplementary, you'd be talking about two angles. So here, this is only talking about one angle. This is the definition of a straight angle.
The next one, C.
Even though we use the mark on
All right. This one, let's see. E says definition of supplementary.
C.
that one's definition of supplementary.
Why do you,
Or is it angle?
why do you say definition of supplementary there?
Because it equals 180.
No.
But is that wrong?
It's already told you
But-
that things exist.
Shh.
Plugging it in.
Say it again.
It's already told you that things are equal to each other, and you're just plugging them in, so it's substitution.
This is substitution.
Because
Yeah,
that-
it already made that statement. It's not, if it was telling you, shh, listen,
Kind of proof.
if it was telling you, if you're going to be using definition of supplementary, you would have been given the two separate angle measures that you already knew were equal to 180.
Yeah, that's already-
Did it give us two angles that we knew were equal to 180 yet? No, right? It didn't give us the two separate numbers. It would have given us both of these numbers. We don't have both of those numbers yet. So that's not definition of supplementary. We don't have two numbers that we know equal 180. What they did was they replaced this equation with the two other values that were given to us. So this is substitution. So the letter was C. Substitution. Property of equality. All right. So now, 7. The last step, what happened? Subtraction, D. And again, could this not be there and have addition property instead?
Yes, but that's
Yeah. So again, just remember, anytime you say subtraction property of equality, if you don't see that as an option, then it's probably going to be addition. All right? Because again, adding a negative is the same as subtracting a positive. All right?
that one maybe not.
Okay.
It should be more like that.
And again, a lot of what will be on the, I would say, out of the ones I've shown you so far, this one, very similar to the style of questions you would see on the FSA, because a lot of times they'll ask you, sometimes just for one blank, sometimes for multiple blanks, but they usually give you some type of word bank to either drag and drop from, or multiple choice to choose from, or drop down menu to choose from. So again, a lot of them, even though this one has a lot of blanks, I'd say this is similar to something that you could see.
I don't
all right?
like when they give me a.
Now again, they might only ask you to fill in number 4, or they might only ask you to fill in number 7. They might not ask you for every step. All right. So again, make sure you read the question. All right. Now we're getting into the triangle. So proving triangles are congruent. Shh. The biggest part of proofs that we did was in this section when we were proving triangles were congruent. Yes.
It said that the SSA triangle that it was congruent, and I got the question wrong. I was really confused.
SSA
Doesn't do it because
doesn't do it. It's HL. So
I was like, what?
I'd have to look at the question. I don't know.
Which one?
Algebraization is mean like that.
Again, SS. So remember, HL. Again, I'd have to see the question. Was it a right triangle? The only way SSA works is with a right triangle. But they shouldn't call it SSA. They should call it HL then. Right? Because SSA isn't enough information. They have to give you a right angle specifically, and then you use the fact that it's HL. Because HL is telling you it's a right triangle with the hypotenuse and a leg. SSA by itself, not enough information. Yeah. I'd have to look at it. The only thing I could guess is that they probably gave you a right triangle. But, again, then it's really HL. All right. On here, So complete the proof below. Again, when we have triangle proofs, which is the most common one, I could almost guarantee you that you're going to see some type of triangle proof on the FSA. All right. You have two triangles that you have to prove are congruent. Now, they might take it further than that. If they go past the step that says we have two congruent triangles and then say you're trying to prove something else, what's the last part going to be? CPCTC. Corresponding parts of congruent triangles are congruent. Again, if you go past saying the triangles are congruent, then it's going to be CPCTC. Because again, once you know the triangles are congruent, guys in the back, once you say that the triangles are congruent, CPCTC is what's telling you all the other parts are now congruent, right? So corresponding parts of congruent triangles are congruent. Now, the top one is what? It's given, right? That's what they told us. Now, look, there's another given, right? We could plug this in. I like filling in my givens. If they want us to fill in more than one thing at a time here, I like to go ahead and get rid of all the givens first. Now, so this one, all right angles are congruent. You're just actually listing these two angles since they were told they are right angles and saying, now with the congruent symbol, they are congruent. So, because again, in order to use your triangle congruency properties, you have to show that there's three parts that are congruent, right? For all those, whoops, I left out the L. For all those different congruency criteria we had, you always have three parts. So, even though they say they're right, we have to physically say they're congruent in order to actually apply one of those congruency criteria. So, on here, again, I also like labeling as we go. So far we have those are congruent. We have these two are congruent. And then it says LP is congruent to LP.
I don't know what you would call that one.
What is it when the same line is in both triangles, therefore it's congruent to itself? It starts with an R. Close, not reflective, reflexive. Say again? No, you're not. Again, you'll be fine. The proof questions usually aren't the hardest questions. Again, they're only going to ask you for certain parts, and hopefully based on the clues they give you, you'll be able to narrow it down to the correct answer. All right? All right, last part. We have three parts. We have three parts. Which three parts do we have? ASA. Now, they could, they can say this a couple ways. They could just say ASA as an abbreviation. They could say, spelling it out, angle, side, angle. They could even go a little further than that. They could say angle, side, angle, congruency theorem, or ASA congruency criteria. Again, just know that it's ASA because they might give it one of a few different ways because they might just say ASA or angle, side, angle. But then they might also add on to their congruency criteria or congruency theorem. All right?
Yes, sir.
We good? All right, let's move on. Now, on this next one, do we need to use CPCTC?
I don't know yet.
I heard no in the back. Why no? We're not doing anything else. Guys, look. Again, if we're stopping on the fact that the triangles are congruent and nothing comes after that, then we can't use CPCTC because CPCTC only will come after the fact that the triangles are congruent. There's no other line there, so no CPCTC here. All right? So now, going through, we know this was given. Again, I'm going to mark as we go. We also know that IL is congruent to KL. That was given. What other piece of information do we know by looking at the triangles? LJ. LJ is congruent to LJ. And you said reflexive. Now,
And the next one is
so which one of our things is this?
side.
Side, angle, side. Yep.
Do you not like my weird ways of remembering it? The side triangle.
So, side angle side, triangle congruency theorem.
Go ahead.
All right? We good? Well, I got lots of examples, and we got like 10 minutes, not even. So, I'm trying to get through as many as possible. All right, let's go to the next one. We good? Again, I'll post stuff to Edsby. I got a few things to post tonight that we've done this week, so I'll post the correct answer in case you didn't get it. I'll post it. All right, next. All right, flowchart proof. Remember, for a flowchart proof, same idea. You're putting the statements in the boxes and the reasons below the box. But a flowchart proof shows kind of an order of thinking. Right? Now, same things are always true here. You should start with some givens. You should end with what you're trying to prove. So, what goes in the last box? Angle A is congruent to angle C, right? What we're trying to prove. Why? CPCTC. Because we proved the triangles are congruent, and we went past that, so now we're using CPCTC to say that those pieces are congruent. So I'm able to finish the end of the proof before I even started the beginning. All right? Now, we have two givens. Guess what those are giving? First two boxes. Now, which one goes where is important, though, because they gave us a reason for the next one. The one dealing with midpoint should follow before midpoint theorem here. So, B is the midpoint of AC. The other given, angle ABD and angle CBD are right angles. All right angles are congruent. So, what's going to go in that blank?
The two angles are congruent.
Yeah. Angle ABD is congruent to angle CBD. B is the midpoint of AC. AB is congruent to CB. Now, really, you could change the order there, but I'm just picky.
That's fair.
All right. There is something else we should know. BD. BD is congruent to itself. Will you most likely have a proof that uses reflexive property? There's a very good chance that you will see reflexive property somewhere on the FSA because it comes up in a lot of proofs. Now, again, it's the one that says that this line, since it's in both triangles, is congruent to itself in both triangles. Now, will it be the one that you have to fill in for? I don't know. It might be one of the ones that's already given to you. You'll definitely see a proof that uses reflexive property somewhere. Whether it's the one you have to fill in for, I don't know. All right, we got three pieces. Which one is this? Side, angle, side, triangle, congruency theorem. All right. Good? Moving on. Let's skip that one for now. I want to make sure that we get to the two paragraph ones, and then we'll come back if we have time. All right. Now, yeah, this was a test question. This was a quiz question, or maybe vice versa. I can't remember. One of them was a test. One of them was a quiz.
I have no memory.
So on here, remember paragraph proofs. Now, for paragraph proofs, it's the same thing. Now, I can't guarantee this, but for some reason, and again, I'm pretty sure this was from a book somewhere. I don't know why. Sometimes paragraph proofs can be a little bit sloppy, and they don't always list every single idea. They should be more detailed than this, because there's some other properties that I feel should be in here. But a lot of times on standardized tests, even the FSA, I feel like there's some things that are left out that could also be part of it. But you still follow the order and make sure you list a reason as to why these things are true. Now, just looking at this, do you know what the length of JK should be? It's going to be 36. But in order to say that, we have to be able to prove why. So we have the paragraph proof here to help us explain why that side must be equal to that one. So, we got these two angles. Shh, hold on. So these two angles, that's this one and this one, are congruent. Why? Because they're right angles, and all right angles are congruent. All right, the next one, NLM, and that one, congruent. They're vertical angles, so vertical angle theorem. Then it says these two are congruent. How do we know those are congruent? They're equal to each other. So what property or theorem or postulate is that, or definition? Huh? So if they're equal, they must be congruent. Definition of congruency, or if you want to be a little more specific, definition of congruent segments. Either one works. Definition of congruent segments. All right. So now we can say the triangles are congruent because ASA. We need to say how the triangle is congruent. So MNL is congruent to
JKL?
and then we know that JK is congruent to because of CPCTC. We went past the fact the triangles are congruent, and we're able to say the other sides are congruent. So, again, if you go past that fact, the reason is CPCTC. All right, let's do another one.
We've got like 4 minutes left. Is that enough?
All right, I know, that's why I skipped the one. Oh, we don't even have that. We have the 2 minutes. All right. This one, shh. So, we have an exterior angle. We're trying to prove the exterior angle theorem. So, angle 4 is congruent to these two. Well, it says we have a triangle. What's equal to 180 because they form a linear pair? Those two, right? Measure of angle 3 plus measure of angle 4. They're a linear pair. Yeah. Linear pair. Two angles next to each other that form a straight line. Linear, meaning line. Linear pair. Two angles form a line. Right? Linear pair. Alright? Alright. So, since blank equals 180 because of triangle sum theorem. Well, triangle sum theorem says all three angles equal 180. So, 1, 2, and 3.
See, this is what I was going on.
Equal 180.
We still have 2 minutes.
And yeah, okay, we're out of time. But this would be substitution. And we're done with that one. Alright. I'll post the answers. I'll take it Monday because I just extended all the online stuff, so I'll take it Monday. You too.